Hi all. So this is Vidya. So as you all know, we are left with the term 3 portions, which majorly covers the concept of linked list. So I'm trying to present it using this video. Please follow this and visualize this as a regular class. Okay. Please take your notebook, pen, pencil, etc. Try to take lecture notes. At the end of this, I'll be posting an assignment in AUMS, which you have to submit it within 1 hour. Okay, so this is to ensure that you have listened to this video presentation. Uh, so please follow these instructions. So let me try to present the linked list. Okay, so we'll be seeing linked list. So linked list is another kind of type of a linear data structure. There are different types of linked list. You can see singly linked list, doubly linked list, circular linked list. Okay, we will be seeing each of this in detail. So today's class is mainly concentrating on singly linked list. Okay, so first of all, let me give you the definition of a linked list. Okay, a linked list is a linear data structure in which the elements are not stored at contiguous memory locations. Please note that point. It is not stored in contiguous memory locations. Till now, we have seen the data structures stack, queue, vectors, hash table. Okay, all this we implemented or we tried to explain it with arrays, whereas arrays is a contiguous memory location, stores the data in continuous memory locations. So linked list here is not stored at contiguous memory locations. Okay, so how is the data stored then? So this data in the linked list is stored using nodes. So the basic building block of a linked list is a node. Now, how will be a node look like? That's here. The node will be having this kind of format where the node will have its own data part and an address part. The address part will point to the next node to which this linked list is built upon. Okay, so that's the node structure. Okay, so you have a data part and an address part. We'll come into the detail of nodes in the upcoming slides. Okay, and the node itself will be associated with an address. Okay, so how is this implemented in C? You have to use pointers. If you are trying to implement this linked list concept, you have to use pointers and structures. Okay, so we'll just, for time being, we are not looking into the implementation side. Please try to understand the concept of linked list. Okay, going to the next slide. Okay, now how will you access the node fields? Okay, so in this diagram or in this picture, you can see data part and an address part. So the earlier part, the node representation, it was represented with two fields, the data part and address part. Now I am dividing the data part into three different fields and you have an address field. Okay, so with this diagram, what you understand is data part is can be divided into multiple data. You can store multiple data in a node. Okay, so here I'll just tell you some terminologies. Okay, with respect to this diagram or with respect to, so this is a generic node representation. a node is having the name temp. Okay, so this node will itself will have an address. Okay, and the address part of this node is pointing to the next node. So this field stores the address of the next node. Okay, now how will you access the elements inside the node? In case of arrays, how do you access an element in an array? With the subscript value, right? The name of the array with the subscript value. Now you are given with node. How will you access the elements inside the node? Okay, so if you want to access data 1, so this is how you can access temp, that's the name of the node, dot the field that you are trying to access. Okay, if you want to access the next node, then you have temp dot next. Hope this is clear how to access the node fields. Now more on data, or sorry, more on nodes. Okay, so what is a node? So node can take any structure, so which is already clear with the previous slide, right? It can take any kind of structure. Now assume that I am trying to create a linked list of your class. Okay, what will be the nodes in this linked list? Yes, each of the student will be the node. Yeah, so what will be the node structure now? You understood, okay? This class, the whole as a linked list. If I represent whole this as a linked list, each of the student is a node. Now you have to define the fields in the node, right? What will be the fields? Yes, you have your roll number, right? You have the name, age, your which branch, etc., right? So for time being, I am just focusing on 3, that is name, roll number, age. Okay, and what will be the address part? Assume that the roll number 1 is pointing to roll number 2, right? So if you are trying to make a demo, please have a pointer. Each of your roll number, previous number, will be having a pointer to the next number. Okay, so roll number 1, say left hand is pointing to roll number 2. Okay, then the roll number 2 have its own data, right? So he will be having name, roll number, and age, and an address part. What will be the address part of roll number 2? He will be having pointer to roll number 3. Like that, the linked list. Hope you are able to visualize what I am trying to tell. Okay, if you have any doubt, please message me in the WhatsApp group created by Surya for exclusively for DS. Okay, so you can visualize that as a data as a linked list now, right? So you have the linked list. Now what is the speciality of the last roll number, right? What is the speciality of the last roll number? Actually, roll number the last roll number need not point to anybody, because the last he is marked as the last node in the linked list or end of the linked list, right? That means the address part of the last node will be set to null. That means there is no more pointer, which represents the end of the linked list. Hope I am clear with that structure. Now, second example. How will you represent polynomial expression as a linked list? What will be the node structure? Okay, so when I am telling this, please make your lecture note. I am again reminding you as in class. Okay, please make your lecture note. First, I have to see in your notebook the linked list of the student. Okay, so you have to make the lecture note. Please don't forget that. linked list. Now the second linked list. Second linked list is what? A polynomial expression. If you are given with a polynomial expression, how will you create the linked list of a polynomial expression? Yes, I'll pause here for a while. Please draw it in your notebook. How will you draw a linked list for an polynomial expression? First, write a polynomial in single variable. Okay, polynomial expression. Then identify what are the features of an polynomial expression. Okay, I'll give you a clue now. Each term in the polynomial expression is having a coefficient and an exponential power for the variable, right? Like that, all the terms. Okay, now what will be the node structure here? Yes, you have a coefficient part and an exponential part, followed by an address. That is a link to the next term in the polynomial expression. Okay, please draw that. Okay, now coming to the third example, how will you represent a list of movies which is directed by a particular director with essential details in the node? You can assume any details. Don't make it too much lengthy, just take it as a 3. Maybe the name of the movie, which year it is released, what is the genre of the movie. Okay, so that will be the linked list of linked list of movies which is directed by a director. Okay, so hope you understood what is a linked list. So I'll just summarize what is a linked list. Linked list is a collection of nodes which are not stored in contiguous memory location. Okay, so when you get any application, you have to make sure what will be the node structure of the application. Okay, some of the applications I have discussed here, that is a student, right? Student is a node. Then you have the polynomial expression, right? Then you have the movies. Okay, so hope you understood the node and linked list. Okay, going to next slide. So what is other properties of linked list? Linked list is a data structure which can change during execution. Okay, successive elements are connected by pointers. Last element points to null. It can grow or shrink in size during execution of a program. It can make just as long as required. Hope these points are clear with the example which we have discussed in the previous slide. Okay, singly linked list. So this is how a singly linked list will be looking like. Okay, so you have a head pointer which points to the first node of a linked list. Okay, so this is a node. Okay, so here I have only one data part and one address. Okay, so this is a data part. So the data part of the node is in the first node, it stores a data called 1. Second node stores the data called 2. Third node 3. Fourth node's data part is 4, and the fifth node's data part is 5. And as I told earlier, each node has its own address, or it is associated with its own address. So the number represented below the node, assume that as a memory address. Okay, so 1000 is the address of this node. 2000 is another address. So as you can see, this is not a contiguous memory location. Okay, so 2000 is another location. 3000 is another address, which stores the third node. 4000, 5000. Okay, so this, the numbers which is represented below the node is a memory address for that node. Clear? Now head is a pointer which points to the first node. So here you can see data part and the address part. So what is this 2000 means? So 2000 is an address of the next node. Okay, that is saved in this node. So you can see 2000. When I tell the address of the next node is 2000, it is actually a link is established between this node and the node in the location 2000. So that is why this link is coming. Clear? Now you can see in the second node, what is the address? Second node's address part is having value 3000. 3000 is nothing but the address of the third node. Okay, so you can see slowly the link has been established in this manner, right? So 3000 is the address of the next node. In the third node, it stores the address of the fourth node, that is 4000, and 5000 is the next node. Hope this values in the node is clear, right? See the last node. Last node's address part is set to null. Okay, that means this is the end of the linked list. No more nodes are linked with this linked list. So with the head, how can you reach the this node? How will you print the data part of this node? What you have to do is head dot next dot data. That means what? Head's next is what? Head is pointing to this node. Head dot. Hope you are making a note of that. Head dot next. The field name is next. Dot data. So next data will be 2. When you print that, you will be getting value 2. Okay. So now if I tell the value, please make a note of that. Head dot next dot next dot next dot data. What will be the value of that? Please make a note of that. Write the answer in your notebook itself. Okay, I'll be asking you to scan the notebook and submit also. It may be one assignment. Okay, so please write note of that. So what was my question? If I am accessing the data as head dot next dot next dot next dot data, what it will be printing? Okay, so that will be 4. So head dot next is this node. This node's next is 3000. That is this node. Sorry, that is this node, right? This node's next is this node. So we have crossed 3 next and dot data. So now my pointer is at this location. Dot data will give me 4. Okay, hope you understood how to access that. Okay, next is a picture of a doubly linked list. What is the difference between the single linked list and doubly linked list with the diagram comparison of diagram? You can see the node structure is different, right? Instead of single address, you have now 2 addresses. Each node is associated with 2 address. So you can see this node. Okay, you have a single data part. Okay, you can have multiple also, but here for easy representation I have taken only single data and 2 address part. One is previous, another one is next. That means this node is having 2 pointer which points to the previous node of this node and the next node of this node. Okay, so you can see each node is associated with 2 pointers. You can see 2 arrows. Okay, and for the first node, right, there is no previous. So the previous part is set to null. Okay, and the second and the next part will be pointing to the address of the next. node, that is 2000. Okay. Now coming to the second node, you have previous node. Previous node is the first node, that is the address of the first node is 1000 and the next node is at 3000, right? Hope this is clear. Okay. And at the end, you can see the last node next will be set to null. Okay. So the first node's previous is a set to null and the last node's next part is a set to null in case of doubly linked list. And you can see it is accessed only by one pointer, that is head node. Next is a circular linked list. Okay. Circular linked list can be a singly or doubly also. Okay. So this is a single circular linked list. Okay. Or circularly singly linked list. Clear. So what is a circular about this? You have an head pointer. All the other are explanations are similar to your singly linked list, but you can see one important difference between the single linked list, where this was assumed as a last node. This last node was set to null. Now what happens? This last node is not set to null. Instead, it is pointing back to the first node in the linked list. Okay, so this is called as circular linked list. Again, you can create circularly doubly linked list also. Okay, where you have to, what will be the change? Please draw a circularly doubly linked list. What will be the difference between the doubly linked list and circularly doubly linked list? Yes, that the first node's previous was set to null in the doubly linked list. Now it will be pointing to the last node, and the last node's next was set to null in doubly linked list. Now it will be pointing to the first node. Okay, please draw that. Okay, now we will see more about singly linked list. Is a type of linked list that is unidirectional, that is, it can be traversed in only one direction from head to the last node. Each node has a data and a pointer to the next node. Shows the linked list. You can see a head which points to the first node of the linked list. Okay, with the help of this head node, you can access all the elements in the linked list. So how to access the elements in the linked list, I have already shown in the previous slides, right? For your knowledge, I'll again tell you. Head dot data means the node is now pointing to the first node, so head dot data is equal to 1. Head dot next means it is 2000, that is the address of the next node. Okay, so that's how you can access the data elements. The next slide, here you can see the singly linked list with a head and the tail pointer. Okay, so you can the tail is indicating the last end of the linked list, which is pointing to the last node in the linked list. Okay, so you are free to decide what kind of representation is required. Do you need to have a tail pointer and head pointer together, or is it enough to have the head pointer alone? So that and all you can decide based on your needs. Now we can see the ADTs, or the operations that you can perform on linked list. Okay, mainly insertion, deletion, searching. Okay, so these are the basic operations that you can do in linked list. So what you have to know, must know the pointer to the first element in the list, that is a head, and what are the operations you can do is insertion and deletion. Okay, so again there are the different types of insertion. You can see insertion at the beginning, or insert at head, insert at tail, at the end of the linked list, and insert at any random position You can specify the data. After this data I want to insert a new element or insert a new node as the third node in the linked list. Whatever way that you want to do, you can decide. So that's a insert at any random place. Same operations that you can do deletion also, that is deletion from the beginning, deletion from end, deletion at any random position, searching or traversing the list is the another operations. Okay, so this class we will be seeing the insertion of an element. Okay, all the insertion operations we will be completing. Okay, so the first operation is insert at head. Okay, so I want to insert a new node with the value 10. You can see the value of the node or the data part of the node will have the value 10. Okay, so a new node with value 10 has to be inserted as a first node in this existing linked list. Okay, so we can see how it is done. So what is the first step you have to think? Okay, the first step here is I have to create a new node because you are increasing the number of nodes in the linked list. So you have to create a new node. So how will you create a new node? Assume that this is your new node. Okay, the name of the new node is temp. The data part of the new node is 10 and it is not pointing to anything now. Okay, so this is a single node. Okay, now in order to insert this new node uh, as a first new node as first, we have to create a new node. Here we have created the new node named temp. Okay, so this step, assume that this step will create a node. Okay, for time being discard about this. This will create a node with name as temp. Okay, then I am setting the data part of the new node, that is temp dot data equal to 10. Okay, so set the node's data part as 10. Then temp dot next is equal to null. Okay, currently it is not pointing to any other node. Okay, so now we have this linked list, right? This whole linked list we have, and we have this node which you have to insert into the linked list. Where is the position? You have to insert this node at the beginning. Okay, that is before 1. Now we have to link the created node to the existing linked list, right? So what is this step 2 which is shown in the yellow color? Step 2 is temp dot next. That is, this null pointer we have to reassign, right? What is the null reassigned value? This null has to be updated, or this null has to point to the existing first element, right? Then only it will become the first element. Yeah, so what is this step? Temp dot next, that is, this null will be now assigned to head. That means this 1000. Okay, so null is now reassigned to 1000. Okay, that's this step 2. You can see this link I have drawn here which is pointing to this. So after execution of step 2, this will be the status of your linked list. Now what is remaining here? Is the linking operation done? Yes, you have linked the new node to the existing linked list. But what point is what point is missing here now? Yes, this head pointer which is now pointing to the second element, right? Yes, so you are not able to access the first element with the head pointer. So what you have to do, one more step is pending, that is the head has to point to the newly inserted node because that is the first node being inserted into the linked list, right? So what is that step? You can see here head is equal to temp. Okay, so when you do the reassignment of the head, what will be the step? You have to do head is equal to temp. So now head is reassigned to this node, and you can see earlier it was null. Now it is having the pointer value is 1000. That is a old first node, right? This was the old first node. This address is now given to the newly created node, right? And head is now pointing to the newly created node. So this will be our final linked list, right? So final linked list is having 10 as the first node, right? Followed by that you have the old linked list 1, 2, 3, 4, 5, and you can see the address of the newly created node is 6000, okay, and the node value which is next value which is pointing to is the 1000, okay. So this shows you the entire step, the whole logic of inserting a new element at the beginning of a linked list. Hope I am clear with that. Okay, now the next step is or next operation, sorry, not step, next operation is to insert a new element at the end of the linked list, okay. That means now we are going to insert a new node after 5, okay. After 5 I have to insert, but this is my status of the linked list, right? What do you have? Only one pointer head which is pointing to the first node, and this is your linked list, right? You can see here already created node is also part of your linked list, okay. So I'm taking this as a sequential process, right? Clear? Okay, now I am going to insert a new node at the end. So what is a essential step there? First of all, you have to create a new node, okay. So that is what I have created here inside this yellow circle. You can see this is a new node which is created. The value of the node is 20 and currently it is not pointing to anything, so I have set it to null, and the address of this node itself is 7000, and the name of the or the pointer or name of the node is last. Okay, so now what is step 2? So we have to reach the end of the linked list, right? We have only a head pointer, but how will you need to reach the node which contains 5, so that after 5 you can link the newly created node called 20 after 5. So I have no pointer which points to the last node now. So what you have to do? You have to traverse the linked list and reach the last node in the linked list. So how to traverse the linked list? Okay. Now can I take this head pointer? Can I take this head pointer and ask head pointer to jump towards and point to the last node? Yes. Give a think about that. No. Okay. You're not allowed to change the head because programmatically it won't show you any error, but logically when you move the head pointer there is no other pointer which can tell you the first node, because you have already moved your head pointer to some other node. So what will be the first node in the linked list, or how can you access the other nodes in the linked list if you move the head pointer further, right? So that is not possible. So what we are trying to do here is we are creating another pointer, temporary pointer as a backup, right? Now this temporary pointer is moved to reach the last node in the linked list. Head pointer is not moved, okay? So you can see here temp is equal to head, right? That means I am pointing temp also to the first node. Now you can see two pointers. This first node is pointed by two pointers, temp and head. Okay. Now I am free to move temp, right? Even if I move temp, I can gather all the other informations of the linked list with the help of the head pointer, because head pointer is still pointing at the first node of the linked list. Okay. Now how will I move the temp pointer to the next node? Okay. So here you can see temp is equal to temp dot next. Okay. So how to move? Temp is equal to temp dot next. When you tell temp is equal to temp dot x, what is a, you're reassigning the value of temp itself. That is temp equal to temp dot next. Temp dot next is 1000, right? So temp is now moved to point to the next node in the linked list. Okay, so those, the movement of or the traversal of the linked list is done using this for loop. Okay, this yellow color highlighted statement. Okay, so C programming statement. Okay, a for loop. But you can see here a semicolon at the end of the for loop. Can you have a semicolon at the end of the for loop? Yes. Okay, so if there is a semicolon at the end of the loop, what is the meaning of that? It is a do nothing loop. Okay, so this loop is not doing anything. Just after condition is checked, it will come and increment. Condition is checked, it will come and increment to the next node. Okay, so this semicolon means it is a do nothing loop. Okay, so after the execution of the statement, temp will be pointing to the end of the linked list. Okay, so I'll tell you how is this done. Temp equal to head. So this is your initialization part of the for loop, right? So I have initialized temp and head pointing to the first node. Then what is done next? You are checking temp dot next not equal to null. Okay, you are checking temp dot next is this 1000, is it equal to null? No, it is pointing to some other node, right? So this condition is true. If the condition is true, it has to enter the loop because the condition is true. So when it enters the loop, it sees a semicolon. That means it is not doing anything. So it will come to the incrementation step. Okay, so here incrementation is moving the temporary pointer to the next name. So temp is equal to temp dot next. So now temp will be moved to this element. Okay, again it comes to the condition checking. In the condition checking, what is done? Temp dot next not equal to null. Now temp is pointing to this node. Okay, now temp is pointing to this node. So it is checking temp dot next. What is temp dot next? Temp dot next is 2000. It is not equal to null. Yeah, so the condition is true. Again it is a do nothing loop. It will jump the temp pointer to the next node, temp equal to temp dot next. So it comes here. Next again, coming to the for loop, condition checking, temp dot next not equal to null. Yes, it is not equal to null, right? It is having value 3000. So again it increments, it comes here, it checks temp dot next not equal to null. No, it is 4000. So temp is moved to the next element. Again temp dot next not equal to null. Yes, the condition is true. So it again jumps to the next node. Now again checks temp dot next not equal to null. The condition is false, right? Now temp dot next is equal to null. Clear? So the condition is false and it exits the for loop. So when it exits the for loop, temp is now pointing to the last node in the linked list. Yes? Are you able to visualize that? Okay. Going to the next slide, you can see here. So after execution of the for loop, this will be the state of the linked list. Head will be pointing to the first node and temp will be pointing to the last node in the linked list. Hope I am clear with that for loop. Now what we have to do, we have this already newly created node available here. The name of the node is last, the data value is 20, the address is 7000. Now what we have to do, we have to include a step which reassigns the pointer of this temp to point to the new node, right? So what is this now? What is the step you can do? Temp dot next is equal to last. That means what, this null is now updated to 7000. That is nothing but the address of the newly created node, right? Yes. So now you have linked the newly created node to the linked list. Hope I am clear with the steps. So what and all you have done to insert a new node at the tail? First is to create a new node. So you created a new node. Then after creating the new node, what you have done? You have to traverse the linked list, right, to reach the last node. So that you have done with the help of the do nothing for loop. So you completed that, and a temporary pointer which points to the last node in the linked list you have done. After that, then you have to do only one pointer reassignment, that is the last node's next part has to be set to the address of the newly created node. Yes? Okay. Now, what is the time complexity of this operation? Yes, if you have only head pointer, what you have done? You had traversed the whole linked list to reach the last node, right? So what is the time complexity here? It is the length of the linked list. Okay, assume that it is n nodes are there, then the time complexity to reach the last node is O of n, and then you had a constant time operation to link this node. So what is the time complexity of inserting a new node at the end of the linked list? It is big O of n. Okay, and one more case is, if there is a tail pointer which points to the last node of the linked list, what will be the time complexity of an insertion operation? You got the answer? Yes. If the tail pointer is pointing at the last node, then you have to do only this pointer reassignment operation, the traversing part. That for loop you can avoid. Then it becomes big O of 1 time complexity. Okay. In that case, you have to invest more space because one extra pointer you are using. Okay, so if you are able to afford with the cost of giving a new space for tail, then the time complexity of insertion at the end will become O of 1. Is it clear? Okay. And what is the time complexity of insertion at head? Insertion at head, are you doing any looping? No. What else you are doing? You are just making some pointer reassignments, right? You are creating a new node and some pointer reassignments you are doing, which will be taking constant amount of time. So it is O of 1 time complexity to insert a new node at the beginning of the linked list. So this will be your final linked list, right? So what is a final linked list? You can see this, right? The last node, the node which contained value 5, and the next part is null. Now it is assigned to a new address, that is 7000, which is the address of newly created node, and that has been linked to your existing linked list. Clear? And you can see the last node, so address part is set to null. So this will be the whole steps that we have already explained it. Okay. Now the last kind of operation is insert at any position. Okay, inserting at any random positions. So this is our linked list. This is our linked list. So you can see 10, 1, 2, 3, 4, 5, 20. That's your linked list. So now I am going to insert a new node after the node which contains 2. Okay, assume that the data part is unique. Okay, there is no duplicate entries in the any of the nodes. Okay, so I can find uniquely 2 or it is not there, but here we are trying to insert at the any random positions. So 2 is there, so I have to insert after this node. So what all things you have to do if you are going to insert a node after 2? Okay, yes, you can tell, you can think. I'll give you some time, right? So to insert a new node after 2, first step is to create a new node, right? So I have created a new node, right? So the name of the node is pause. Okay, the value is 50 and the address is currently the next pointer is currently set to null, and the address of this node is 8000. Okay, so what all things you have to do if this node, this new node called pause, has to be inserted after 2, that is at this position, what all things you have to do? This address, right, first of all you have to reach this position, right? So you will be again like inserting at the end, you have to search for 2 in this, right? So using a for loop you will check the data part of each of the node that you are traversing, and when you get that data part equal to 2, you have to exit from the for loop. That means temp has to point to this node. Okay, so after traversing that, what you have to do? The address of this node is now currently pointing to 3, right? But I am going to insert a new node after 2. So this 3000 has to be updated to 8000. Clear? And what you have to do? This null, which is going to be inserted after this 2, has to point to this node, that is the node containing 3. Yes, you understood this point, right? That is between 2 and 3 I am inserting a new node with value 50. Okay, so the corresponding address change also has to be done. Clear? So we'll see that. Okay, so find the position to insert in the new node, that is a step, right? So what you have done, I have assigned a temp equal to head, right? Then I'm checking whether temp.data not equal to 2. Okay, so here temp.data is not equal to 2. The condition is true. If the condition is true, it is a do nothing for loop. There is nothing to do, so it will come here and temp equal to temp dot next. It will point to here. Again checks temp dot data is not equal to 2. Condition is true. So again it goes to the do nothing loop and increments a pointer or moves the pointer to the next node. So temp equal to temp dot next. Clear? So now I have this node. Now I am checking temp dot data not equal to 2, but temp dot data is equal to 2, right? So the condition becomes false and it exits the for loop. Okay, so when the for loop is exiting, the temp is pointing to the node with value 2. Okay, so that explanation is given here in this box. Okay, so after execution of the for loop, you can see temp will be pointing to this node. Now what you have to do, as I told her earlier, this address has to be updated, right? So what is done here? Pause dot next. Okay, this pause dot next, this part, this is now changed to temp dot next. Sorry, I have a mistake in the statement. Okay, it is only temp dot next, it is not temp dot next dot next. Okay, now is it correct? Pos dot next, that is null, has to be changed to temp dot next, that is 3000. Yes, that is 50. After 50, 3 has to come. What is the address of 3? Which is 3000. So what happens? This link, this dotted link is now established with the first statement, that is pos dot next is equal to temp dot next. Now what you have to do next? Temp dot next. Now this 3000 has to be updated. Temp dot next should be equal to pos. So this link is established. So when once it is done, what is the status? This 3000 will be updated to address of this node, that is 8000, and this null will be updated to 3000. Let's see that. You can see that 3000 is updated to 8000 and this null is now updated to 3000. Note the changes of the address in the node highlighted in green. Okay, is this clear? So that will be our final linked list head. So this was the first operation we have done, right? Insertion at the beginning. Okay, 10 was inserted at the beginning, then you have done insertion at the end. 20 was inserted at the end, then insert at any random position. We selected to insert a node after 2. So this is done. Clear? Please be clear with the values in the next part so that you understand what is this linked list is. Okay, now a quick question. What will be the effect of swapping these two steps? Okay, here also I have a mistake, so I'll delete this. Next, save it and play. Okay, so if I am exchanging these two steps, okay, so earlier in our random position insertion, this was the step. Okay, this was the step. Now I am exchanging these two steps. If I am exchanging these two steps, can you draw a diagram how the link is updated if I am exchanging these two steps? Okay, a kind of this kind of diagram. Only draw the, I think this dotted lines, it will be changing. Okay, so I'm going to swap these two steps. What will be the effect of swapping these two steps and draw the linked list with respect to these two steps? Okay, so that was the first class, okay, on linked list, where we have seen all kinds of insertion. Okay, so I'll be posting an assignment on inserting into the linked list. Please do that. Thank you.